Okay, so good afternoon, everyone. Today, SMC will be started. My name is Firdausi Zaragandes, will be the presenter for today's webinar discussing the GIS-based network analysis for the road network in SuperMap iDesktop. So firstly, I would like to give you a brief introduction of SuperMap technology. Okay, so SuperMap was founded in 1997 by Dr. Esung Song. For approximately 23 years, we have helped humans in solving various problems with GIS as the main foundation. We have about 4,000 employees spread in all around the world, 1,000 partners coming from more than 30 countries, and 38 branch offices and subsidiaries. And this one is our 5 main key technologies that are the basis for solving spatial problems encountered using SuperMap platform. First one is the Big Data GIS. So we support to do the whole process of big data. It's very popular technology in recent years, and I believe it's not only in China but also in the world. In all the overseas markets, they have made a lot of use of this Big Data GIS. Big Data GIS is divided into 3 parts. Those are the spatial big data visualization, spatial big data analysis and processing, and spatial big data storage management. And we have also artificial intelligence or AI and GIS integration. So it's based on the basic support of data, database, and framework so as to realize 3 functions related to artificial intelligence. Those are the GeoAI, AI for GIS, and GIS for AI. And the third one is the 3D GIS. So we have developed our function leads to 3D by 3D modeling from 2009 by integrating some technology like data model, scene construction, spatial analysis, and software form. And the fourth one is the distributed GIS. So this one is our new value just released in the last 2020 in the GTC conference. We have our capability to manage spatial computing in more than one machine, including for analytics, storage, and visualization. And it has 4 components: the distributed geospatial data engine, geoblockchain, distributed geospatial analysis and processing technologies, cloud native and edge GIS technologies. And the last one is the cross-platform. So not only in Windows, SuperMap also able to be open in Linux operating system. And our product was served in various terminals such as desktop, cloud-based, and mobile as well. And today we will be discussing more details on our solution for road network in SuperMap iDesktop by taking advantage of network analysis. Okay, now let's start with the question of what is network analysis. So network analysis in essence is a process to solve the practical problem by analysis in network model, such as the path analysis, surface area analysis, and closest facility. Find the closest facility. And this solution can be utilized by this kind of industry. So at present, network analysis has been widely used in many industries. We will give you some examples, such as electronic navigation, telecommunication, transportation, and also tourism. And actually can be more than that, as long as they have network data need to be managed and analyzed spatially. And these are more specific practical problems that can be solved by using SuperMap platform. For example, we are going to know the shortest route from point A to point B, or in the tourist attractions, how to choose the route which pass the most points of the interest at one time, or how big is the coverage area of customer of a newly opened supermarket. or how to dispatch the recent fire engines for the rescue, and also to find a distributor deliver in all his delivery tasks in the shortest time. All of these problems, the main things is to find the best routes, and it can be solved by using network analysis. In today's webinar, we will discuss the live demonstration of network analysis, transportation network analysis in SuperMap iDesktop. And this is the software we will use for today's demonstration, SuperMap iDesktop 10.1.1. This is our latest version, 10i 2020 SP1. You can download it in our official website, and it will be 90 days free trial in the beginning. Okay, before I move to the live demonstration, let me tell you the workflow for today's demonstration. So first, we will create a network model data because we cannot do the analysis for the line dataset or point dataset. We need to create a network model data to analyze them by using transportation network analysis. And then we can implement some analysis such as the optimal path analysis, traveling salesman problem or TSP analysis, closest facility analysis, surface area analysis, and the last one is the location-allocation analysis. So, firstly, before creating a model, I want to explain the network model in SuperMap. There are two kinds of SuperMap network models. The first one is the transportation network model, and the second one is the facility network model. Both models can be represented by two-dimensional network and three-dimensional network. So, what is the difference between transportation network and the public facilities network? The main differences between these two models are as follows. So the transportation network model is a non-directional network, and the most common one is route transportation network. Traffic network analysis is usually used for route search and location, while the facility network model is a directional network, usually including natural gas pipeline, rivers, and so on. And in this webinar, we mainly discuss the traffic network model because the remain we already discussed it in the previous webinar about the pipeline modeling and analysis. Okay. What is network? The network is a model which is composed of a group of interrelated arcs, nodes, and their attributes. So the network can express the real workloads, work roads, pipeline, and etc. As shown in the figure above, in this presentation, the network not only has the abstracted topological relationship between arc and nodes, but also has geometric location and geographic attribute feature of GIS spatial data. And what do we mean by topological relationship? Topological relationship is the cross correlation between geographic objects in spatial location, such as the connection relationship of nodes and lines and polygons. Therefore, the following describes the basic concepts involved in the network model. Those are, the first one is nodes, which are the places that arcs connect network, this one. And then second one, we have arcs. Arc segment is an edge in the network connecting with the other arcs by nodes. And the third one, we have network resistance, which is the cost of nodes and arc that is basically stored in the attribute field as the resistance fields. And we also have center points, obstacle edges, obstacle points, and also the turntable. Turntable, which save the cost of turning. Turning itself is the process that an arc passes through the middle node to arrive to arrive the adjacent arc. And then how to create the network model. We need to prepare dataset to build the network data. Point dataset is optional, but you need to at least have line dataset. It can be line dataset of a route line or a pipeline or perhaps railway and etc. And then you need to prepare the field information of the network dataset to ensure that the line data used to build the network contains a field that denotes the network resistance. So even though you don't have the point dataset, you can still be able to create the network dataset because you can have a check in the split lines at the intersection to automatically generate the points in each of the intersection. Okay, I think now I will move to the SuperMap iDesktop to show you how to build the network model. Okay, this is the visualization of the SuperMap iDesktop. Okay, I think I need to delete it first. Actually, previously I already opened the workspace, but I will show you from the beginning how to open the workspace. So, wait. And anyway, if you all have any question related with my presentation today, you can drop your question in the Q&A chat box, and my colleagues will help to answer your questions. Okay, so this is the visualization of the SuperMap iDesktop. Please make sure you use the latest version, which is the 10.1.1 version of iDesktop. And firstly, we will open the existing workspace about the that contain the data we will use for today operation. You can right click in the untitled workspace and open file workspace. And here I have one project file, workspace file, namely Changchun. I will open this one. Okay, and this workspace contain one data source, namely Changchun, and also it has already two maps. And this data source, the Changchun data source, store many kind of data sets. But for today, we will not use the entire data, only a particular of it, such as the roadnet data, this one, the stop points, barrier points, hospital, and also governments. But actually, if you want to know how all of this data looks like, if we give a style to them all, you can open the existing map, this one. Just double click on the junction map to get to know how the data looks like. Okay, so this is how the data looks like. I already give a styling and different symbol, different color for the data, and it will be looks like this. Basically, this is kind of a base map for base map. So there is a polygon data that representing building or green area, and then we have road line, railway, and etc. But for today, we will only use specific data. So I will just close this, and we will create a network model for the roadnet line data. We can right click and add a new map to take a look how the data looks like. So this is how the data looks like, the roadnet line data. This is part of the map that I have presented to you before, but particular for the road only. And we will create a network model for this data. So we will not be able to achieve the transportation analysis for the line data, but we need to create a network model for the line data. To do so, we can go to the traffic analysis, network path topology, and we have the structure to the network feature here. You can have a click on that and the build network dataset will appear. Since previously I have selected the root-net line dataset in the workspace manager, so it will automatically import it in the build network dataset. But if you don't get it automatically here, you can add it manually by click add here and select the data that you are willing to create the network dataset. And then should you don't want to use this data, you can just erase it by using this remove button. Here I have the split settings. If you have the point data that represented the intersection of each arc or each line, you can just import it here and it will split the line by points you had before. But if you don't have one, you can split lines at intersection by have a check in this box and it will generate a points in each of intersections. And in the result settings, you can define the data source to save your result and also define the dataset name after you create the network dataset. And then click OK if you think you have set all the parameters. Okay, so it will be appeared here under the Changchun data source. I have the Changchun network. It consists of two different datasets. The first one is the line network and the second one is the node. Now let's take a look how this looks like by just drag them to the open map window. If there is a prompt appear whether to ask you whether to create a spatial index to speed up the display, you just have a click yes on this prompt. So it will raise the performance. Okay, now actually you can just it will look like the previous data before we create the network dataset. But the different things is that if we have a check in the network dataset, the attribute table, it stores different information with the previous data. So this is the original data. It stores this kind of information. But in the network dataset, the one that we have created before, it stores special information, especially this one, SMF node and the SMT node. So the SMF node and SMT node is representing the from node and to node for each arc. So one record here representing one arc, and one arc have two different nodes, the from and to. So this arc will have the direction from this 5709 node to this 5710 node. That's why we will taking advantage of this information to create the route, the traffic route by using the traffic analysis later on. Okay, now we will close this and I will go back to the presentation before we move to the specific analysis. Okay, we have created the network model. Now we will go to try one analysis, which is the optimal path analysis. So this the optimal path analysis is one of the commonly used functions of network analysis. The optimal path analysis is used to find the path of the least resistance between 2 points in the network. The least resistance has different meanings. It can be those based on a single factor like the shortest time, lowest cost, or others. or maybe the best traffic condition or others. And the shortest route is a special case of the single factor of the optimal path. And you can define it as a weight later on. This one, forward weight and backward weight. The first figure is showing the difference result of optimal path analysis if we check the least edges parameters. These parameters will analyze the route with the least number of edges. For example, the number of edges that the red route is less than the number of edges of the green route. But actually, the overall length for the result route may not be the shortest. So as you can see here, the red one is only have one edge between the stations, and for the green line is have three edges between the stations. So it will give you different result should you define the different weights. Because for this case, we define the edges as the weight or as the resistance. And before performing any network analysis based on the network dataset, we need to set the environment settings. The environment settings is used to set the global parameters of network analysis. Okay, now let's take a look how it looks like in the SuperMap iDesktop. Okay, so you can go to the traffic analysis and select the optimal path analysis. Okay, it will appear in the right window. We have the environment and also instance management because it will automatically check on the instance management and environment box here. But should you not willing to open one of the window, you can just uncheck here. And you can have a check in the path guide, and it will give you more details about the step-by-step of the route after you successfully generate the route. But I will close it later and open it should I have implemented one of the analysis. Okay, so in the environment, I think we need to activate one of the path analysis again, this one. So in the environment, we have style settings, and then we have the traffic rule setting, turntable, and then weight. This is to define the resistance, whether you want to use the minimal cost or maybe time, speed, the most effective way to avoid the traffic jam or the shortest. You can define the weight here and also create a flow direction, analysis area settings, pipeline model settings. We have used this in the previous SuperMap mini classroom webinar. We have also the check loops and create network model file. But for today, we will just show you the simple one to achieve the traffic analysis. So in the environment, first you need to make sure that you already set the correct network dataset, which is the Changzhou network, the one that we have created before. And here I will define the SM length. SM length is the length of each arc, such as this one. The length of this one should be one arc. One arc has two edges in each of the edge. And it will be the length will be the weight for today analysis. And you need to define the node ID, the edge ID, the start node. I have explained before the SMF node and also the SMT node. And you can define the result settings and the tracing analysis. And in the instance management, we will define the station points, the barrier, and also get the result later on after we define the stations and barrier. Actually, barrier is just optional. Should you don't have one, it's no problem. You still be able to execute the analysis. Okay. Actually, there is two options for you to define the stations. You can manually pick the points or you can import the existing points. But for today, I will import the existing points. You can right click in the stations and import the points. And I will use the stop points and click OK. So this is the distribution of the stations point. I have 4 stations here. Start from the stations 1, 2, 3 until 4. And now let's take a look at the result by click run. There's a message here. So apparently my data has some errors. I'm not sure where is the error, but you still be able to continue the operation even the data have some error. It may be because of the topology error. I will check it later, but we can still be able to continue the operation. And you can click yes, and it will continue the operation. So in the optimal path analysis, it will give you the result from the path from the stations 1, station 2, 3 until 4. Because the order of the stations is already defined before, and it will give you the most shortest path from the stations for each stations to each other. And should you define some barrier points, let me define it first. I have some barrier points. It's located here between the stations 1 to stations 2 and between stations 3 to stations 4, the result will be different. Now let's execute it. And yeah, this is the result. So it will avoid the barrier point and looking for another way, but still be the shortest path to go from the stations 1 to station 2 and so on. And if you want to know the path guide, you can have a click in the path guide and enable the setting. Here in the instant management, enable the path guide and it will be appear here. So it will guide you from the start stop, walk about 30 meters head ahead and then turn left, go ahead again, turn left, and etc. It will be defined here to assist you to go from the stations 1 to the stations 4 if you enable the path guide. And if you're willing to set the list edges as the parameters, you can have a check in the list edges here. Okay, now I will go back to the presentation. Before I move to the second analysis. So first we have the optimal paths analysis, and second one we have the traveling salesman problem or TSP analysis. And it's different with the optimal paths analysis. Actually, the main point is just the same, to find the best paths from the first stations to the another one. But TSP analysis is unordered path analysis. So the TSP analysis can decide the order to visit the nodes, and its target is to get the minimum or the close to the minimum sum of the travel route impedances. So the difference between the TSP analysis and optimal path analysis is the method to visit all the network nodes. As you can see here, in the optimal path analysis, since you have defined the first station, the second one, the third, and the fourth, so the result will assist you to go from the first to the second to the third as you defined before. But in the TSP analysis, this analysis will define the routes not by the order that already defined before, but it will define based on the most effective way and the most shortest path, the summary shortest path between the each of the stations. So as you can see here, it says that after we go to the stops 1, we will not go to the stops 2 because of the stop 4 is nearest rather than stops 2. So it will guide you to go to the stops 4 first, and then go to the stops 2, and eventually you go to the stops 3. So that's why it's different, because this one is based on the order, but this one is not the order, but it will give you the final result with the summary of the list impedances. Okay, now let's take a look how it looks like in the SuperMap iDesktop. Now let's activate the find TSP path. Okay, so actually for the environment setting, it's just the same like before. You can define anything should you willing to have another setting, but for today I will just make it default. And now I will import the station stop by click import. I will use the stop point, the same like before. I will not use any barrier for today. And now I will click run to get the result. So as you can see here, the result is different. Previously we get the result from the stations 1 to stations 2 because the optimal path is referred to the order, but for the traveling sales path analysis, it says that better to go to the stations 4 first before to go to the another stations, because of the stations 4 is nearest rather than the other stations, and so on and so forth. So it will perhaps it will be the most effective way to go to the stations 4 until to the 3 to the 2, or rather than go to the stations 2 first. Okay, and you can also enable the path guide to get to know the step-by-step route as follow. So from the start stop, you need to walk around 30 meters ahead and then turn left and go ahead again, and so on and so forth. Okay, so I will go back to the presentation. Okay, the third analysis is the closest facility analysis. The basic concept of the closest facility analysis is to find the nearest facility points to the known points or event points. You can find one or more facility points that can be reached by the minimum cost. The analysis result is the optimal path between the event point to the facility points. For example, a traffic accident happens in this point event stop, and the injured people need to be sent to the nearest hospital for emergency treatment within 10 minutes. The surrounding hospitals, which cannot be reached within 10 minutes, won't be taken into consideration. In this case, the location of the accident is an event point, and the surrounding hospitals are the facility points. Facility points here are the hospitals. In essence, the closest facility query is path analysis as well. And during the analysis, we should consider the sections that have barrier points and barrier edges that cannot be passed. Okay, so now let's take a look at the analysis in SuperMap iDesktop. Now we will activate the find closest facility. Okay, I will close the path guide. And for the find closest facility, I will import my points. It will be act as the facility point, not as an event stop. So I will right click in the facility stop. As you can see here, the instance management information is a bit different with the previous one with the optimal path or with the TSP, because here we have the event stop and also facility stop. we can define the facility stop, import the existing points, and for today I will use the hospital points. And since the hospital point have one field, one name field, so we can use that as the label. We will use the name field as the name field, and then click OK. It has around 85 records data, and this is the visualization of the distribution. And now we need to define the event stop. We need to have a click in the event stop. Now let's define the event stop. Let's say here. Also, let's pretend that this event stop is the injury case, where the injury case is happened, and we need to looking for the 5 nearest hospital surrounding of the event stop. So we can have a setting parameter here and define the number of the facility number, let's say 5. So we will looking for the 5 nearest hospital and click OK. Now execute it, and this is the 5 nearest hospital. These are the Children's Hospital of Changchun City, the number 2 hospital, Jilin University, and others. And also it will give you different color for each different route from the event stop to the hospital. All right, awesome. Okay, I think I will go back to the presentation again to explain to you another analysis. Okay, the fourth analysis is the surface area analysis. So surface area analysis is to conditionally find the scope of the surface area that the specified surface stations can provide in terms of the route within each coverage. So actually some other people may use just like buffer analysis from the center point to get to know the coverage area, and they will get kind of a circle after they do the buffer analysis. But actually it's totally different with the surface area analysis, because in the surface area analysis, the coverage, it will consider the road path. So it not only consider the radius but also the path between the surface stop to the surface, the outmost far surface area. Such as in this presentation, I have defined one surface stop here, and this surface, and then I define the surface radius, such as let's say 100, and 100 in the 100 here is means the most, it means that the outmost part of this coverage area, it has 100 path route in a distance. So I mean it's like the distance between these points and these points by using the route line is about 100. So that's why the result will not be looks like a circle, because it consider the path or the route. And also you can involve other parameters, such as if you're willing to know the best path by using the parameters such as the velocity, or perhaps the time, or perhaps the most efficient way to avoid the traffic jam and others, you can still be able to involve that parameters. So in essence, the surface stops is the center point of the surface, providing the location of the surface, and the surface area is the area that within a certain impedance, taking specified points as the center and containing all the accessible edges. Simply, it refers to the area that is served by a location according to some certain conditions to provide a particular service. For example, the governed area of a community police station according to the administrative divisions. And in the network analysis, the network nodes with resources are abstracted as a service stops, and the maximum distance of the service stops is abstracted as a service radius. So in the analysis results, you can get the service network and service area in the form of polygon. The analysis is generally used to evaluate and analyze the service scopes of the public facilities in terms of routes such as the post office, hospital, supermarket, and etc. So as to provide the reference for selecting the optimal locations of the public facilities. Okay, so the main idea is this analysis is in terms of the route within its coverage. Now let's take a look how it looks like in the SuperMap iDesktop. Okay, I will activate the surface area analysis. We'll be asked to define the surface stop. I will import my existing points. I will use the government's points here, but since the total record data in the government is too many, so I will just do query for the data. So I will only use the data with SMID less than 10. So I will define it SMID less than 10 and click OK. Click OK. Now we can define the surface radius. I will use 500. And click OK. Now execute it. And this is the result. So this is the surface top, and the purple area here is the surface area of the surface top in terms of the route within 500 coverage. So it consider the path route, not only just calculate the distance from in terms of 500 meters from the surface top. Okay, now let's go back to the presentation. Okay, so this one will be the last analysis for today, the location allocation analysis. So the location allocation is to select the optimal location for one or more service providers in a certain region, so that the facilities can be one of the most cost-effective way to provide services and merchandises. Location allocation is more than just how to locate, which also needs to allocate the demands of the demanding points to the appropriate facility service area. For example, a city has 15 hospitals as follows, whose distributions are shown in the figure. And now I want to select 7 out of 15 hospitals as the city's centralized hospital for the physical examination of the college entrance test. So I will just looking for the most optimal location of the hospital to be the hospital for some program in my city. And we can use the location analysis to support to get to know the most effective hospital in my case. Okay, sorry. Now I will activate the location allocation analysis. This one. And I will pick a random point that will be act as the hospitals. Okay, let's say I will set it here. Around 15 center points that will be act as a hospital and execute it. Sorry, we need to define the parameters first. Because here I only set a 2 center count, so it will only give you 2 partition, but I will set it as 7 to follow my case before and execute it again, and it will be give you this kind of result. So the case, I will repeat the case. The case is I want to looking for the most effective hospital based on its location. uh, Only 7 out of the 15 hospital, and the result is as follow. Center 1, 2, 4, 5, 6, 7, 8 is considered as the most effective hospital to be used to support my program in my city, to for the college entrance examination. And as you can see here, based on its location, it's always located in the middle of each partition. So one partition is defined different area. And also there is always one center hospital of each partition. So the center point here is considered as the most effective hospital to be selected in each of this area. Okay. And if you're willing to change the number of center counts, you can just set it in the parameter settings in the location allocation parameter settings here. Now I will go back to my presentation. Okay, so I think that one, it should be the last one for today webinar. We have tried 5 different analyses. Start from the optimal path analysis, traveling sales path analysis, find closest facility, service area, and also the location allocation analysis. And I will share with you the material, the PPT, and also the data for you to try it by your own. You can download it in this link I put in this presentation. And should you have done to try by your own, you can submit it to the link SMC web submission before the 8th of April 2021 to get a certificate from us. Okay, I think that's all for today. Thank you for joining our webinar and see you in the next SMC.